Now you have understood the concept of escape velocity. So what happens when we throw any body with a velocity, when we give it a velocity which is equal to its escape velocity, it escapes the Earth's gravitational force, but from there it will stop over there. It is not going to move anywhere. It is at rest over there in the space. Only the thing is, it will not fall back to the Earth because it is now no longer under the gravitational pull. Okay, so when a body is projected upwards with an escape velocity, it escapes the Earth's gravitational pull and it stays over there. It is at a state of rest. Now we will see certain terminologies for a body when it is on the surface of the Earth and when it is at an infinite distance from the Earth. Page number 13. Now on the surface of Earth, the kinetic energy, we know the formula, it is 1/2 mv square. Okay. Now they have written v square ESK because they are taking with respect to the escape velocity, because when we are throwing a body to escape the Earth's gravitational pull, so what will be the velocity? It will be the escape velocity. So v escape is written. In case of infinite distance from the Earth, what did I say you? When it escapes the Earth's pull, the body is not moving, the body is at rest over there. Okay, so when it is at rest, its kinetic energy will be 0. Now coming to the potential energy, on the surface of the Earth, this particular body is having potential energy as minus gmm upon r. We have seen that earlier. Now in this case, at the infinite distance where it is away, out of the, already escaped the Earth's gravitational pull, there we know that the distance is infinite. So in the denominator, instead of r, infinity will come. If infinity is there in the denominator, the whole expression becomes 0. So potential energy is also 0 when it has escaped. Now total energy of a body, total mechanical energy of a body is equal to kinetic energy plus potential energy. So here in case of on the surface of Earth, let that be E1, that will be kinetic plus potential, that is 1/2 mv square escape minus gmm upon r. And over here it will be kinetic, let it be E2 at that infinite distance where it has escaped, kinetic plus potential, and that is 0. Now according to the law of conservation of energy, you have studied that energy can neither be created nor destroyed. It can only be converted from one form to another, and thus the total amount of energy in the universe always remains constant. Now this means that energy cannot be created nor destroyed. It is always conserved. So the total energy, this E1, should be equal to E2. The total energy of the body when it was on the surface of the Earth was E1, and the total energy of the body, जब वो infinite, वही body जब infinite distance पे चला जाता है, Earth's gravitational force को escape कर लेता है, then its total energy is E2. Body is same, उसका energy destroy नहीं हो सकता है. That means E1 must be equal to E2. Okay. Now going further, as I said you, from the principle of conservation of energy, E1 is equal to E2. So 1/2 mv square escape minus gmm upon r will be equal to 0. Now keep only v square on the LHS and send everything to the RHS. So this minus will become positive gmm upon r. This 2 will go to the numerator, m will come down, and this m will cancel the m in the numerator. So you get v square escape is equal to 2gm upon r. So v escape is equal to root of 2gm upon r. And we know that that is equal to root of 2 and small g and r. This is a substitution done. And that is equal to root of 2 into 9.8, that is the value of g, and r is the radius of Earth. Okay, and that is equal to 11.2 km per second. So this means that if any spacecrafts which are sent to the moon or the other planets, they must have their initial velocity larger than the escape velocity, so that they can overcome the Earth's gravitational attraction and can travel to these objects. If you give exactly 11.2, it will escape and stay there. If you want it to move further, then you have to give more than 11.2 km per second. Those who have not understood this, how this small g has come, that derivation I will put it on the PDF. Now let us know what do you mean by weightlessness in space. Now you must have seen in the videos or the movies that the space travelers or the objects in the spacecraft, they all seem to be floating in the air. Why do you think this happens? First, the first foremost point will come that maybe the value of g is 0. There is no gravitational pull acting on them, and that is why they are floating. No, that is not so. The space station or the spacecraft is at a height where the value of g is not 0. It is just 11% less. The reason is that at that height, the spacecraft is under the influence of only one force, that is Earth's gravitational force, and that is why it is in the state of free fall. And the spacecraft is in the state of free fall, means all the people who are inside it, the astronauts, the objects, all are in a free fall state, and that is why they appear to be floating. And we have seen that the velocity of the free fall does not depend upon the properties of an object. It is the same for the spacecraft, same for the travelers, and same for all the objects in the craft. And that is why if a traveler releases any object from her hand, if she throws anything from her hand, it will remain stationary and appear to be weightless.